boys and girls. Today we're going to do our 6-7 study link measuring angles with a protractor. First, estimate whether the angles measure more or less than 90 degrees. Then, use a half circle protractor to measure them. So you'll see I have my half circle protractor. I'm going to start by lining up the center of my protractor with the vertex of angle A. Remember, the vertex is where the two rays meet. And I'm going to rotate my protractor so that the 0 is in line with the ray at the bottom. Now I know that angle A is going to be less than a 90-degree angle because it's smaller than a square corner or smaller than an L, so it's an acute angle. And I'm just about lined up. And it looks like, there we go. It looks like the measure of angle A is about, I'm going to say it's about 60 degrees. So in number 1, angle A measures about 60 degrees, which would be an acute angle. Now let's look at number 2, angle B. If you look at angle B in number 2, remember to look at the directional arc, and we can see that this angle down here is bigger than a square corner, or larger than 90 degrees, so that's going to be an obtuse angle. So I know when I measure, I should get something larger than 90 degrees. Again, I'm going to start by lining up the 0 on my protractor, the bottom ray of angle B, and you want to measure or line it up so that you're always measuring that directional arc. You don't want to measure the opposite side that doesn't have the arc. So we'll line up our protractor. Now once you have your protractor lined up with the vertex and the bottom ray of the angle so that you can measure how large that directional arc is, or the angle is, I see that the other ray of my angle measures just about 150 degrees. So we're going to say that angle B measures 150 degrees, which would be an obtuse angle. Now let's look at number 3, or angle C. Again, I'm going to turn my protractor so that I can measure the inside of the angle, or the directional arc. So I'll line up the 0 with the first ray. I'll line up the center of my protractor with the vertex of the angle. And then we'll measure the angle to see just about how far it goes. Now I see it's somewhere between 80 and 90, and it looks like halfway between 80 and 90 right here is 85. So it looks like we might be just slightly less than the halfway mark. Right before 85 degrees would be 84 degrees. So we're going to say that angle C measures about 84 degrees. Now let's look at problem number 4. We have angle QRS. So I'll take my half circle protractor, and I'm going to line up the center with the vertex. So we'll turn that around. And line up the bottom of my protractor, or the 0, with the bottom ray. I'll turn that protractor just a little bit and maybe adjust it a little more. And you can see here that the top ray of my angle is right in between 100 and 110 degrees. So we'll say that angle QRS measures about 105 degrees. So it's just slightly larger than a 90-degree angle, which makes it obtuse. All right, let's have a look at number 5, angle NOP. O being the vertex. And you know, this time I'm going to use the opposite side of my protractor. So I'm going to flip it over and I'm going to use now the numbers on the inside because I'm going to start with the 0 over here. So I'll turn my protractor because you really can use either side depending on what's easiest for you, depending on which way the angle is facing. All right, so I'm at 0 degrees, starting with the numbers on the inside since this is where the angle starts. Here's my 0. And I'm going to measure the angle. It looks like it's somewhere in between 30 and 40. It's just a little more than 30, a bit less than 40. There would be 31, there would be 32. I think that angle measures just about 32 degrees. It's definitely smaller than 90 degrees. It's an acute angle. So we'll say angle NOP is 32 degrees. And then we look at the try this problem, angle KLM. Now, if you look, the directional arc here is on the outside. So that means we're actually measuring this large angle over here rather than the inside or the smaller angle here. So since this angle goes all the way around, it's much larger than a square corner. So it's definitely going to be more than 90 degrees. Some people get fooled and measure the smaller angle on the inside here because that's more common, but you have to look at that directional arc and that tells you you want to measure this larger angle or the angle that's bigger than 90 degrees. So I'm going to again measure with the 0 on the inside. So I'm going to rotate my protractor. Now this is tricky because it looks like it might even be larger than a 180 degree angle. So if that's the case, that's going to be difficult to measure. Let's see. Because if I start with the protractor at 0 lined up with the beginning of the angle here, I see that my 180 degree protractor doesn't really work because I can't measure the full angle. Even if I go all the way around my protractor, I get to 180 degrees and that stops there and the angle keeps going. So what could I do? I guess I could use a full circle protractor, but the directions told me to use a half circle protractor. Does anyone remember how many degrees are in one full circle? Because if you look at this angle, it almost goes all the way around a complete circle. If you said 360 degrees, you would be correct. So let's do this. Let's measure the smaller angle on the inside, and then let's subtract that angle from 360. So I'm going to go back to 0, and I'm going to actually, since I'm measuring an angle over here, I'm going to use the 0 on the outside, or the numbers on the top of my half circle protractor. And then we'll rotate it so that we can line that 0 up with the bottom ray. And then once that 0 is all lined up with your bottom ray and the center of your protractor is lined up just like that, we can see that the smaller angle here is 60 degrees. So if the smaller angle is 60 degrees and a full circle measures 360 degrees, then, so now I can see that the full circle, 360 degrees, minus this 60-degree angle here means that the larger angle must be equivalent to 300 degrees, because together the smaller angle combined with the larger angle would be about 300 degrees to make a total of 360 degrees. So we will say in number 6 that angle KLM measures 300 degrees. All right, so now let's look at the practice problems. We have in number 7, 93 times 6. So I'm going to make a lattice, separate it for 2-digit number 93 times 6. Make my diagonals going from corner to corner and corner to corner. And then we'll say, and now we can set the problem up by saying 93 times 6. Well, we know 3 times 6 is 18, so we'll put the 110 and the 8 ones in their respective triangles. And then we know 9 times 6 equals 54. So we'll put the 5 tens in the top triangle and the 4 ones in the bottom triangle. And then, just to refresh your memory, when we solve lattice problems, we have got to add along the diagonals. So we'll do 8 plus nothing else, 4 plus 1, and 5 plus nothing else. So 8 plus nothing equals 8, 4 plus 1 equals 5, and 5 plus nothing equals 5, for an answer of 551 for problem number, or 558 for problem number 7. The product is 558. All right, now take a look at problem number 8. We have 547 times 7. So we'll draw a lattice, make a long rectangle, separate it into 3 spots for 3 digits. And then, of course, we'll separate each rectangle or square into triangles by going from the upper right diagonal to the lower left diagonal. There's 2 triangles there, 2 more there, and 2 more there. Now we're ready to do the problem. 547 times 7. Well, we know 7 times 7 is 49. So we'll put our 4 tens, 9 ones. We know 4 times 7 is 28. And my 2 and my 8. And we know 5 times 7 equals 35. 3 tens, 5 ones. And again, you want to remember to add along the diagonals. So we'll go like that, like that, like that, and like that. All right, so now we have 9 plus nothing equals 9. 4 plus 8 equals 12. So put down the 2 and carry the 1 into the next column. And then 1 plus 2 is 3, plus 5 more equals 8. And then 3 plus nothing else equals 3. So for problem 8, the product of 547 times 7 equals 3,829. Now let's solve problem number 9. We have 48 times 39, so we're going to need to make a lattice that's a 2 by 2. So we'll separate it into 2 columns and 2 rows. And we'll draw our diagonals from the upper right corner to the lower left corner. All of the boxes. Upper right to lower left. Upper right to lower left. All right, so let's solve number 9. 48 times 39. Once you have your lattice and your problems set up, let's do 8 times 3, which gives us 24. So we'll say 2 tens, 4 ones. 8 times 9, which gives us 72. 4 times 3, which gives us 12. And 9 times 4, which gives us 36. Now we'll add diagonally to find our final product. 2 plus nothing equals 2. 4 plus 7 is 11. Plus 6 more is 17. So we'll put down the 7, carry the 1 to the next diagonal. 1 plus 2 is 3. Plus 2 more is 5. Plus 3 more equals 8. And then 1 plus nothing equals 1. So the final product for number 9, 48 times 39, equals 1,872. And last but not least, number 10, 51 times 64. So let's start by doing 1 times 6, which is 0 tens and 6 ones. 1 times 4, which is 4. So again, we have 0 tens, and then 4 ones. 5 times 6 gives us 30. And 5 times 4 equals 20. Now add diagonally. 4 plus nothing is 4. 6 plus 0 more is 6. 0 plus 2 equals 2. And 3 plus nothing else equals 3. So the final product for number 10, 51 times 64, equals 3,264. Well, hey, thanks for working so hard. Hope you're staying warm out there in this winter weather, and I'll see you for more math tomorrow. Keep up the great work.